Hi, I'm Sven. One more thing about quantum computing. Quantum computing is the holy grail of computing. It can solve mathematical optimization problems more or less instantly. Okay, no. But it's true that there are great expectations. So today, let's have a look at how quantum computing is different from regular computing. Welcome to Obtaino. A lot of people explain quantum computing overly simplified. This is understandable, but it leads to totally wrong conclusions at the same time. There are two important concepts in computing. How is information stored and how is information processed? In our everyday von Neumann architecture, information is stored in bits, atomic units that are either 0 or 1. Information is processed by looking at some bits and doing calculations. Now, quantum computing does not use bits, but qubits. These do not only sound more quantum, we often hear that they could be 0 and 1 at the same time. Which is, how to put it, not true. Instead, qubits are neither 0 nor 1 nor both. They are in a state called superposition, which is something entirely different. This superposition state is characterized by a kind of distance from being 0 and from being 1, called amplitudes. This means that there are endless variations of the superposition state of a qubit. But we cannot process qubits like bits. As soon as we look at a qubit, it collapses and becomes a regular bit. The probability of collapsing into 0 or collapsing into 1 is correlated with its amplitudes. This means that the outcome is probabilistic and that we cannot do calculations by evaluating qubits directly. It sounds scary, but luckily, computing with qubits is possible anyway. The physical key is to interfere with their amplitudes and therefore tweak the probabilities of the result of the collapse. And also, qubits are actually linear equations with complex numbers. That is, the state of a qubit can be related to states of other qubits by huge linear equation systems. A computer based on linear equation systems with complex numbers which can be tweaked by magnetic pulses? How cool is that? Quantum computing works on qubits, which are in a state called superposition. Quantum computers are basically encodings of complex linear equation systems, but their result is probabilistic, not deterministic. This means that we are looking into two huge topics: the potential that we can see in statistical applications like machine learning and optimization, and the challenges that arise from this probabilistic behavior. Well, among others. So, if you are interested in a deep dive into the quantum potential in our field, let us know in the comments. See you next time and stay safe!